Here are solutions to test number 2 for ECE 376 for fall 2025. In this test, we're looking at C programming on a PIC processor along with some statistics. The first problem is go from a flowchart to a C program. Now, the processor we're using is a PIC 18F4620 on a custom PCB. So the PCB we're using in this class is one that you build yourself. This has got very specific I/O pins connected to the PIC processor. What that means is that if you use ChatGPT or something else, not that anyone ever would, but if you did use that, you get the wrong answers because, again, every embedded system has slightly different connections. We're looking at the ones for this class. Now, the first problem is given the flowchart, convert to C. So that kind of goes block by block, just like we did in assembly, only now using C code. If I want to make port B input, port C output, the C code is tris B is FF, tris C equals 0. That makes all pins on port B input, all pins on port C output. And additionally, you need to make everything binary. No points off if you forget that. Just won't run if you actually do try to program it. Next block. To set two variables to 0, I'll set time to 0, port C to 0. And presumably, I'll have to declare these variables before I use them, otherwise C code won't like it. This is the start of an infinite loop. That's a while one loop right here. Check. If RB0 equals 0, I want to clear time and port C. So this is like a door. If the door is open for 30 seconds, I want the lights to blink on and off once a second. If it closes, I reset my timer. So when it's 0, door closed, I reset the time, clear port C. That's this section of code. Otherwise, I'm going to increment time, wait 1 second, and there's a custom C routine in the LCD library called wait millisecond that waits roughly 1 millisecond for each count. 1,000 milliseconds is one second. I want to toggle the lights on port C, and there's a couple ways to do this. If time is greater than 30, I want to toggle all the LEDs. One way to do that is exclusive OR with FF. Exclusive OR 1 is a toggle. Another way to do it is a tilde, port C. That takes the ones complement. If I do not port C, that doesn't quite work. What not does is 0 goes to 1, 1 goes to 0. So that just toggles bit 0, not all the bits. And then close the while loop. That's problem number 1. Problem number 2. On our PIC board, we have an LCD display. I'm connected to port D. To drive it, there's a bunch of LCD routines. And again, if you use ChatGPT, again, not that anyone ever would, but if you did, you'd get the wrong answer, because ChatGPT does not know how this LCD is connected to your PIC processor. We have a couple LCD routines we've been using in this course. It's in LCD port D. With it, you've got LCD move, LCD right, LCD out. To move to a certain spot, I move to that spot, so this is 00, 08, 10, 18, move to that spot, and then send out an integer. So A, B, C, D are integers that I send to the display. If I just send a floating point number, it's received as an integer. So if I have 123.45, actually, let's just make that 23.45. When I receive it as an integer, it'll lose the fraction and just receive the number 23. Display with 2 digits, no decimal points. If, on the other hand, I want to display it as a fraction, the way the LCD out routine works is it receives an integer. So to convert this to the integer 2345, I need to multiply by 100. Then I get 2345. I can then display that as in 4 digits and insert a decimal point at the second one. So that's problem number 2. Problem 3. If I read an analog number on A to D converter, what that means is the voltage. The A to D, well, the voltage is proportional. Full scale is 1023. This is that percentage of 5 2.023 volts. The resistance, the voltage is R over R plus 2200, solving backwards. The resistance is V over 5 minus V times 2200. The resistance is 1495 ohms. Then plug that in this equation. The light level is 7.46 lux. So just from the A to D reading, I can tell you volts, resistance, and light level. Problem number 4. Given this data, this is the average temperature in degrees F in Minneapolis and Fargo in the month of November. Using a t-test, what's the chance that Fargo will be warmer than Minneapolis this coming November? Well, the t-test just works for a single distribution, so the trick is I create a new distribution, W. That's Minneapolis minus Fargo, so call this A, call that B. This is A minus B. If I do that, the mean of W is the mean of A minus mean of B plus 5.8 degrees. The variance of W is the variance of A plus the variance of B, 8.94, take the square root, 2.9. So this is what W looks like. It's a bell-shaped curve. The center is at 5.8 degrees. And what I want to know is how far is 0 from 5.8? What's this area? Well, to do that, I find the t-score. How far is 5.8 from 0 in terms of standard deviations? It's 1.99 standard deviations away. From a t-table or a stat track, or whatever you prefer, 1.99 t-score with sample size of 5, meaning 4 degrees of freedom, with 4 degrees of freedom corresponds to an area of 5.8%. So this is 5.8%. There's a 5.8% chance that Fargo will be warmer than Minneapolis this coming year. Problem B. From this data, what's the chance that actually Fargo is warmer than Minneapolis? Now, you know, if you live up here, that's not really likely. Basically, 0% chance. But if I only had 5 data points, I can't be 100% certain. The way you do that is the same as before, but for populations, I divide the variance by the sample size. So now I have a sample size of 5. Divide Minneapolis' variance by 5, Fargo's variance by 5, take the square root. There's the standard deviation for the population. The t-score for the population is 4.45. So what that does is this is an individual. For populations, I know more about populations than individuals. The variance shrinks down by the square root of n. The variance drops by n. Standard deviation drops by the square root of n. So now 0 is 4.45 standard deviations away. From a t-table, 4.45 standard deviations is right about here. About a 0.5% chance that I just had bad data. Fargo really is warmer than Minneapolis. Just the data, by luck, didn't show it. Not likely, but there is a chance. Actually, Fargo is colder. It's problem 4. Problem 5 is a chi-square test. Now, in 2025, Fargo has hit 6 record highs, 2 record lows. Is this an average year? Well, to do that with a chi-square test, I take the expected probability. If this is an average year, well, any given year, any given day has got a 1 in 126 chance of being a record high. 1 in 126 chance of being a record low. 124 out of 126 just being neither. There are 296 days, so that's n. Take n times p. This is the expected number of record highs we should have as of today. Expected number of record lows, expected non-record days. Here's what we really have. To do a chi-squared score, I take the difference squared divided by np, difference squared divided by np, difference squared divided by np, add them all up, I get a chi-squared value. To convert that to a probability, I have 3 bins, meaning 2 degrees of freedom. I look at 2 degrees of freedom, right here. Okay, 2 degrees of freedom, this line. Look for the number 5.76. and that's right about here. On StatTrak, it's actually 94.39%. So there's the 94% chance that 2025 is not a normal year, that something's up. That's chi-square test, and that is test number 2 for ECE 376.